Alright everybody, welcome to the first actual content video for the course. My apologies for the rain. I don't control the sky, but this video does have to get recorded at some point, and now is when I'm going to do so. Alright, in this video, we are going to be talking through section 2.1 of your book, which is functions and their graphs. So, this is kind of some review from pre-calculus. Next video will be 2, but it's still important to kind of go over and make sure we're all on the same page about things. So, what is a function? At its core, a function is a map, really, from one set to another set. If you're confused about what a set is, go take a look at the handout I put on Canvas. But yeah, it's a map saying, hey, I have some stuff over in one set here. Let's call it set A. And I have some stuff in set B. And I want to take stuff from set A, maybe an element X, to another element in B. Well, I'm going to define a function f, and I'm going to say that x goes to f of x under the function f. So really f is a map from A into B. That's how we should think about functions. Formally, let's write down a definition. Definitions are the most important thing in any math class, so highly recommend if you want to take notes on things, take notes on definitions. Examples are probably helpful too, though. So, a function f. Please note, the function's name is f, not f of x. If we put in of x or of t or whatever, that's just the input to the function, but really the function's name is f. A function f is a rule that assigns to each element x in a set capital A exactly one element. And we'll just erase this little part right down here to continue the definition. So, exactly one element called f of x in a set B. So, all this definition is saying is, yep, f is a map that goes from A to B, and x goes to exactly one thing. So everything gets mapped over, but doesn't get mapped to like here and here, just to the one place. So that's what a function is. We call A the domain of the function. The domain of a function is essentially the set of all inputs to the function, and that's what's demonstrated by the picture here. B is called the codomain, but we don't often care about the entire codomain. What we care about is something called the range. So here for domain, we might write dom f is equal to A. Here we're going to define another set called range f. So the range of f is the set range f. You might also see im of f, which is short for image of f. Range f equal to the set of all f of x, where x runs through the domain. of the function. So, what is this? Well, let's say maybe we have a bunch of elements over in A. And they get sent over to B by F. Maybe this one curves all the way around here. But let's say B might have some more things inside of it than just the outputs of F. Well, we don't really care about these three elements of B that aren't outputs of F. As long as we're talking about the function F, I really only care about these ones. And this is the set that we call the range of F, the set of all possible outputs, and it sits inside of the codomain. Alright, so those are kind of the three most crucial parts to any function. Where is it going from? What is it going to? And then, of course, the actual rule that defines the function. There go my notes. Alright, so in this class, along with basically every math class you've ever done so far, you have specifically dealt with functions going from some subset of the real numbers to another subset of the real numbers, and that's going to continue for this class. In fact, the kind of calculus on steroids class is known as real analysis, and yeah, it's called real analysis because it specifically deals with properties of the real numbers. Working with subsets of the real numbers is a nice thing because it means we can actually write down the rules, right? You can do arrow diagrams like this, but when you're working with maybe the whole real numbers, I can't draw down infinitely many arrows. But I can write something like f of x equal to x squared plus 1, and we all understand that it means, hey, for any input x, you're going to square it and then add 1. So this allows you to address, essentially, your map for infinitely many points without having to do a diagram with infinitely many arrows. Alright, what is next? We should probably talk about how to actually compute the domain and range of functions. So let's do it. And we're all very thankful that YouTube has a skip function so you don't have to sit around and watch me erase forwards all the time. Alright, so again, the domain of a function is the set of all possible inputs to the function. So, for instance, let f of x equal x cubed. If I don't put any restrictions onto this function, its domain is going to be all real numbers. This is the standard domain for a function. We're going to, at least in this class, assume that all functions have domain of the real numbers unless we're told otherwise or unless something would go wrong trying to plug it in. So let's see examples of 1 when we're told otherwise and 2 when something would go wrong. For example, we could let f of x, or maybe say g of x, equal x cubed again, but I'm going to specify that negative 1 is less than or equal to x, less than or equal to 2. So now the domain of g is going to be the interval, closed interval, negative 1 to positive 2. Both inclusive brackets since we have less than or equal to signs. So g is only defined between negative 1 and 2. we artificially restricted the domain. And if we were to graph, f of x would look, meh. That should pass through the origin. Something like that. But g of x would be a restriction onto a smaller portion of f. So f will continue on. Alright, so that's how we can artificially restrict the domain. But what about that case I mentioned when things go wrong? What can go wrong? So when we define functions, there's really only two things that can go wrong, which is nice because it means we only have a couple things to check. 1, dividing by 0. 2, square root of a negative number. Can never divide by 0. For those of you who haven't seen why, it's actually a cool little thing. Let's say 1 divided by 0 was some number. Let's call it c. Okay. Well, if 1 divided by 0, maybe not even c, let's give it a value. Let's say 1 over 0 was 7. This would work for any number. Okay. Well then, multiplying by 0 on both sides, we get this, which means, those should cancel out. 1 is equal to 0. Well, that doesn't work. So 1 over 0 can't be a real number. Well, let's say 1 over 0 was infinity. Okay, well then 2 times 1 over 0 is 2 times infinity, which means 2 divided by 0 is infinity times 2, just infinity over again. So these two tell us that 1 over 0 is equal to 2 over 0. Multiplying both sides by 0 will give you 1 is equal to 2. Again, a problem. So we cannot ever divide by 0. Similarly, you cannot take the square root of a negative number, at least when you're working with just real numbers. If you want to go use complex numbers, you can. But in this course, we're going to focus on real numbers, so we won't. And those are going to be our two restrictions for a domain. As long as we're not told that there's further restrictions. Divide by 0 error and square root of a negative error. Alright, so let's compute one or two domains. I'm going to assume that you've seen all of this before since you've passed a pre-calculus class, and therefore I'm not going to do too many examples for it. So let's find the following domains. First, let's do f of x equal to 1 divided by x minus 1 times x minus 2. And let's do f of t equal to 1 minus t divided by the square root of t. So you should pause the video here, take a couple minutes, try these on your own, and then unpause and we'll be able to go through them together. Alright, hopefully now you have had a chance to try these problems on your own. Let's do them together. For part A, okay, I know that we have to watch out for divide by 0 errors and square root of negative errors. I see no square roots in A, so we're automatically safe for part 2. But I do see a fraction, which means there's a chance of divide by 0 error. Well, when does that happen? What we do is we solve for when x minus 1 times x minus 2 is not equal to 0. And this will give us the set of all valid things. Okay, well if x minus 1 times x minus 2 is not equal to 0, This whole thing is going to be 0 if either factor is 0, if and only if either factor is 0. So this means that x is not equal to positive 1 or positive 2. Because if I plug in 1, this first factor is 0. If I plug in 2, this second factor is 0, which means their product would be 0. Okay, so that's going to be our final domain. Domain of f is going to be the set of all real numbers such that x is not equal to 1 or 2. You could also express this in interval notation as negative infinity to 1, union 1 to 2, union 2 to infinity. Or we remember from the set notation handout, which hopefully you've looked at, that union is gluing together these disparate intervals into one big set. Okay, let's do part B. I see that we again have a fraction, so we need to worry about divide by 0 errors, and we have a square root, so we need to worry about square root of negative errors. So, let's take care of the divide by 0 first. We solve square root of t not equal 0. Squaring both sides means that t cannot be equal to 0 squared, but 0 squared is just 0. Cool, so we know t cannot be 0. How the square root of a negative part? Well, for the square root of a negative, I need whatever's inside of the square root to be greater than or equal to 0. Okay, so those are our two conditions. I need t not equal to 0, and I need it greater than or equal to 0. So we glue those two conditions together, and we say that the domain of this function f will be the set of all t in R such that t is strictly greater than 0. Since I need to be greater than or equal to, but not equal to. You could also write this as the interval 0 to infinity, where 0 is going to be open since we can't have it in. Alright, so those are a couple basic examples of computing the domain. Computing the range is a bit more difficult in general. The easiest way typically is to graph it and see it from that. So let's talk about how to do that. Right, because you're trying to find the set of all possible outputs to your function, which means you would have to go through every possible input, plug it in, and see what you get out. And that is difficult to do. It comes more with practice. I'm not going to be asking you guys to compute very many ranges. Maybe some on like this week's quiz or whatever, but apart from that, not really. So, yeah, not really worth it most of the time. Let's talk about how to compute domain and range off the graph, though, because that is helpful. So, let's say that given the graph of a function, we can find the domain and range of that function. Okay, we might say, how? Let's say that this is our function. Let's call that A, B, C, and D. So we have our labeled graph for this function here. We can actually read the domain and range of our function f right off the graph. The domain of f is the set of all x values for which the function is defined, right? Because it's the set of all possible inputs for the function. Well, if we have an input, what the graph of a function does is it shows all your input-output pairs. So everywhere we see f defined on the x-axis, is going to go into the domain of the function. So here, f is defined from a up until b. It's defined everywhere between a and b, except at a. So the domain of f would be a, b, where we'd have an open parenthesis at a, because we're not including it, open circle, and a closed bracket at b, because we do include that in our domain since we have a closed circle here. That's what the graph is telling us to do. We can also read the range right off. The range is the same idea, except we check the y-axis instead of the x-axis. It's just all possible outputs, which are all possible y values that the function contains. So here we would have c to d. Alright, so that's in general how you would find the domain and range of a function given its graph. And that's all I really want to talk about for functions and their graphs. Obviously, there's some more background information. If you don't know like the vertical line test and everything, you might want to brush up on that. That's all in the book, but it's review, so I will leave it to you guys. And yeah, this is all the important stuff for our course. Have a great rest of your day, and I'll see you in the next video.